Check it work? I don't know. I'm going to go over that next, though, in just a second. All right. So let's look at this one real quick. Let me guess help you guys out. So I want to give you guys some advice, basically, if we were looking at how we write these as products into factors. So what I want you guys to see is basically when we're going from factor form, when we're going from when we're going from factor form to zeros, like if we have something, x minus 2 times x plus 1 equals 0, we can write this as x equals 2. We basically say x minus 2 equals 0 and x plus 1 equals 0, and then we solve. That's how we basically get the other sign, right? That's how it's like the opposite sign, because you had to solve. You set them equal to 0 using the zero product property, because it's a product equal to 0. You set them each factor equal to 0, and then you go ahead and solve. So basically, guys, bless you, if we want to work our way backwards, an easy way to think about this is taking your zeros, setting them equal to 0, and then whatever they are equal to 0, that's their factor. Okay? So that's helpful in this problem, because if I have my zeros, I have 3 of them. So I could say x equals 2, x equals 1/3, and x equals -1. Right? Now if I want to solve them for 0, x minus 2 equals 0, x minus 1/3 equals 0, and x plus 1 equals 0. Now I've just found all 3 of my factors. Okay? However, if I was going to multiply these out, I now have a fraction. And you guys agree with me, fractions are not very fun to be doing operations with, right? So there's another way that we could solve for this. Instead of subtracting a 1/3, couldn't we multiply by a 3 on both sides? Subtract a 1. So therefore, my factor is 3x minus 1 equals 0. When I solve this for x, do I still get positive 1/3? Yes. So this is right. There's nothing wrong with it. But why would you want to do fractions if you didn't have to? Right? And again, usually in polynomials, we don't want fractional coefficients anyway. So my recommendation, and usually how my answers will be provided, is without fractions. OK? Now I can write everything. X minus 2, doesn't say anything else. 3x minus 1. And then here, this is going to be x plus 1. But this is now raised to the second power, because it tells us the multiplicity. So that is basically the equation in factored form. If I wanted to multiply this out, then basically what I want to do is choose 2 factors to multiply at a time. So if I was choosing 2 factors here, I would just apply distributive property in this case. So I'd have 3x squared minus 6x minus x plus 2. Just remember, guys, that's still inside parentheses. Times, then I can factor this, x plus 1 squared. That's a binomial squared, guys. Remember, binomial squareds get multiplied to perfect square trinomials. So I really don't even have to do factoring here. I automatically already know this is going to be the first term squared, the second term squared, and then 2 times these 2 terms. So it'd be x squared plus 2x plus 1. Now I can just combine my like terms here. 3x squared minus 7x plus 2 times x squared plus 2x plus 1. And now we have the box method. Or, I'm sorry, we don't have to use box method. You can use distributive property if you want to. But what I've found out is usually when we have 2 larger terms multiplied by each other, it's kind of easiest to group them or think of them as length and width of a box. So then I just take one term, 3x squared, put up top, plus 2. And this one becomes x squared plus 2x plus 1. And now I basically just find the length of the width of the whole box. So therefore, this becomes 3x to the 4th minus 7x cubed plus 2x squared plus 6x cubed minus 14x plus 4x.
14x squared.
It is 14x squared, thank you. Minus 7x, and then plus 2. And again, the nice thing about the box method is as long as you have things in descending powers, you can combine. I don't know why I wrote a plus. you can combine your common terms. So therefore, my final answer is going to be y equals 3x to the fourth minus x cubed, because that's positive 6x squared minus 7x cubed, or 6x cubed minus 7x cubed. This becomes a negative 11, a negative 9 x squared. Combine these two as a negative 3x plus 2. And that'd be my equation in standard form. OK? Now, I'm going to work out the other answer, but because this is early,